All right, everybody. So today's lesson is lesson 3.3, and we're going to call this slope formula and, oh wait, there's more, constant difference. And I want you guys to write the boxed goal on your notes. So just here's what we're going to be doing. You know, we will understand the slope formula and, I bet you'll never guess, now you got it, constant difference. And if you miss it, it's up on the board still. Okay? So this is what we're trying to get through today. Where we'll know we had a good lesson if by the end of it we can say, okay, I get what slope formula is, I get what constant difference is. So what I want to do is thinking about Scott's push-ups, that exercise we just did. What I want to do is I want to kind of think about what that looks like as a graph. Okay? So I'm just going to sketch out a quick little graph here. It may not be the most precise graph, but we need kind of a visual aid to kind of understand what's going on here. Okay, so, this will represent the day. This will represent the day. This will represent the number of push-ups he does. Push-ups. Okay, so I got like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's probably fine. And then I'll have day 1, day 2, day 3, day 4, etc., etc., etc. And so when we look at our homework and we see what that is, we see on day 1 he did 3 push-ups. So on day 1 he did 3, and if I were to write this as an ordered pair, I'd say 1, 3. On day 1 he did 3 push-ups. I did that in red. On day 2 he did 5 push-ups. If I write that as an order pair, I'd say 2, 5. On day 3, let's go orange. On day 3, he did 7 push-ups. Day 3, he did 7. That looks like 7. 3, 7. And on day 4, let's go pink. On day 4, he did 9 push-ups. Day 4, he did 9 push-ups. So all I did was I took the bar graph from Scott's workout, this bar graph here, 1, 3, 2, 5, 3, 7, 4, 9, and I just did it in a XY plane. That's kind of something we're a little bit more familiar with, something we work with a little bit more in algebra. So all I did was convert that into this graph. And so when I'm looking at this graph, well, what can I see here? Well, I see that these points, well, they kind of make a line, don't they? And in fact, they do make a line. They're in a straight line. My slight errors notwithstanding. I did kind of just sketch it. But they make a line here. And lines are something we know a lot about. We spent the last 2 units talking about lines. We know that lines have a slope. We know that lines have an intercept. We know how they behave. We know that there are infinite answers. Those are all things we know about lines. But when I'm looking at just a series of points, sometimes it's useful to understand what the slope is. And so what we've done as mathematicians is we've discovered this thing called the slope formula. Slope formula. Because when I look at this, when I look at it as a line, I can figure out what the slope is. I can go, okay, I rise. How many do I rise? 2. I run 1. So I know my slope. But let's imagine I didn't have the luxury of this graph, and I just wanted to look at the points. If I didn't have this graph here, if it wasn't there, because it wasn't there in our original problem, but I had the points, I would have the points. Well, I know that the point 1, 3 is there. I know that the point 2, 5 is there. I know that the point 3, 7 is there. And I know that the point 4, 9 is there. 4, 9. Okay. If I didn't have the luxury of the graph, could I still figure out what the slope of this line is? And the answer, of course, is absolutely, and I'm going to show you how. It's called the slope formula. And so what we do is we set it up like this. The slope formula is m equals y2 minus y1 all over x2 minus x1. And so this is incredibly important. And so what does this mean? Okay, so this means we need 2 points. Okay, we need 2, I'm going to make it like all caps and underline, points. Okay, one point we're going to call x1, y1. The other point we're going to call x2, y2. All that those little lowercase, those little subscripts, that's what we call it, a subscript. The 1 just means that's 1 point. The 2 means that's a second point. That's all that it means. That's all that it means. And so as long as we have 2 points, we can figure out the slope. So I'm going to do that a couple times here. So for my first example, I'm going to say my first point is, I don't know, the red point, because that's the one we started with. So the y value of my first point is 3. The x value is 1. I'll say the green point is my second point. So the y value is 5. The x value is 2. 5 minus 3 is 2. 2 minus 1 is 1. So my slope is 2. That's how I use the formula. Does that kind of make sense? Now here's the thing. It doesn't matter which points you pick. You can pick any points. So what I'm going to do instead now is I'm going to do the exact same thing. I'm just going to pick 2 different points. Okay? This time I'll pick the orange point as my y1, or as my point 1. So y1 is 7, x1 is 3. And I'll pick my pink point as my second point. So my y is 9, my x is 4. Okay, now I'm going to solve it. 9 minus 7 is 2, 4 minus 3 is 1, that's 2, that's m. I have found my slope. We can even pick any other points. It doesn't matter. I'll roll it at random. Okay, 1, 2, 3, 4. 1. So I'll have the red point. I'll have the red point be my first one. So 3, 1. Now I'm going to roll again. Well, it can't be 1 again. That doesn't quite work. 3. So I'll have the orange point be my second point. Okay? And I'm still going to get the slope. 7 minus 3 is 4. 3 minus 1 is 2. 4 divided by 2 is 2. Whoops, why did I write a 3? What am I thinking? And all of that equals my slope. Does that make sense? All we need are 2 points. We need to know this formula. This is the key part. This is the money part. This is what gets you paid. As long as we know this and we know 2 points, we can find the slope. We don't need a graph. We don't need to count. We don't need to count 1, 2, 1. We don't have to do that anymore. We can just look at the points, plug it into this formula, figure out the slope. Any questions on this? Feeling good? Can I get thumbs up, crystal clear, thumbs sideways, kind of foggy, thumbs down, Victor, we might want to come back to this. All right, cool. I see most of us give me thumbs. I don't know what's going on unless all of you guys give me thumbs. So next time I ask that, make sure you do that. So here's the next concept. The next concept is we're going to talk about a thing called constant difference. Okay? What does this mean? What does the word constant mean? Constant. Essen? Doesn't change? Yeah. Something solid. Does its thing day in, day out. It's constant. It's not changing. What does the word difference mean, though? Difference. Is- Not the same?
The amount of change?
Amount of change? So you're already taking it the next step. You're thinking the difference is going to be the amount of change between things. Awesome. So here's what I'm going to do. I'm going to look at our buddy, what's his name, Scott. Our buddy Scott's workout, and I'm going to just make a quick little chart on what day, how many push-ups did he do. Okay, I'm just going to make a quick little chart. So on day 1, he did 3. On day 2, he did 5. On day 3, he did 7. On day 4, he did 9. Okay? Easy enough, right? And so when I'm looking at this, to get from 3 to 5, what do? Well, I add 2, right? To get from 5 to 7, I add 2. To get to from 7 to 9, I add 2. And so we can see that I am constantly adding 2. So if I were to ask you what the constant difference of his push-up routine is, what would you tell me it is? 2. You would say that the constant difference is 2. Does that make sense? Thumbs up, like, yeah, Victor, I get it. I'm at 2. Now here's the thing that I want you guys to see. I want you guys to see this relationship. What if I asked you what the slope of his workout routine is? What would you tell me that is? 2. You would tell me it's 2. So what is the relationship between constant difference and slope? They're the same gosh darn thing. It's just a different way of communicating the same information. Does that make sense? So I may ask you for what's the slope of the line. I may ask you what the constant difference is. And I hope that you guys see that they are the same thing. And in fact, when we're saying he does 2 more push-ups each day, I want us to get to the point where when we hear that, he's doing 2 more push-ups each day. The cell grows by 4 each day. Whatever it is, I want you to be able to see that and say, okay, so the slope is 4. The slope is 2. To be able to see that whatever this growth is, that's the slope. Beautiful, right? Everything works together in a nice, neat little puzzle piece. All right, that's it for the lesson today, guys. Pretty simple, but just using vocabulary to describe stuff that we already know.